And welcome everybody to my talk about hackers are in before it exists, protecting your DevOps software supply chain. Thanks for having me. Great to be able to speak for your people finally. And let's get on with it. So I'm Leo Visser. I'm from the Netherlands and I'm a cloud consultant at OGD ICT-diensten, which is a buzzword, and it means that I work with a lot of buzzwords. So infrastructure as code, CI/CD, automation, agile, DevOps, the whole shebang. And I've done several different things in the past, varying from more programming to sysops to more like being a technical lead. So what are we going to talk about today? So first, I want to dive a little bit into what do we want? What are we afraid of, or what should we be afraid of? Then, how bad is it exactly? Of course, nowadays everybody talks about AI. So, how will AI save us? And what else can we do? And I'm going to do some demos. And at the end, there's time for questions. So please try to keep the questions to the end or put them in the chat. And then let's go on to what we should be afraid of. So, I've done programming several different languages. Just wait, Ellen. But I've done several different languages, but a lot of people who are working with like IT systems, they do PowerShell. So often when I'm giving this talk, I provide this code, and there might be something wrong with this code. And yes, Ellen already said it in the chat. There's two things being wrong. One of it was it said az.accounts with 3 C's. Also, something I'm always nitpicky about is you should probably also specify where you want to download it from, just in case there might be more repositories. So for the people who don't know PowerShell, what this script does is it installs a module provided by Microsoft, which lets you connect to Azure. You will get a subscription. So you will just get some information about the subscription and you would disconnect again. Very simple. A lot of people connect to Azure this way to do some basic admin tasks. So having these 3 C's in it doesn't look that bad. Your code might not function. So how bad is it exactly? Well, let's find out. So now I'm going to share my screen and hope everything works. Let me quickly get this back up. So I've got a virtual machine over here. And of course, the Teams thing and the virtual machine thing pop over each other. So now I can't go back easily. So Teams go away. And seriously, I want to drag the... There you go. So let me move this one to the side. You don't see it, but I will. And what I'm going to do is I'm going to first install a little repository. I could do this demo with the PSGallery, so the official PowerShell gallery managed by Microsoft, but I'm going to do some naughty things and they won't like me if this is always in the PowerShell gallery. So for the purposes of this demonstration, I'm going to kind of install my own PowerShell gallery for a moment, just to show what could go wrong here. Let me first, before we do this, show you a little bit about this. So what I'm going to do is I'm going to connect with a repository in Azure DevOps. And to do this, I need a PAT token. I need a token to authenticate. These tokens I can create here in Azure DevOps. So I've got a token already. I'm going to create a new token, which normally I would scope for different permissions, because today I'm lazy. I'm just going to give it full access because this token will be removed after this demonstration anyways. I'm not going to show you the token, even though it probably doesn't matter. And let's go back here. So, because you're probably going to see the token anyways, because to properly use it and easily copy it, I also need it here. So let me pass over the token. And let me pass over the code. So I'm going to run this code, which will then register a library for me. And this is the, yeah. So it asked me to enter the token. I'm going to enter this. And now we wait for a second. So I'm going to install the module az.accounts with 3 C's accidentally. This last part would normally not be there, but for the sake of the demonstration, it's now here. So I do this with my own repository instead of the PSGallery. I could just upload this module I created, which in a moment we're going to look at, to the PowerShell gallery. But Microsoft might not like me that much if I do. So let's run this. And let's wait for a moment until it's installed. And it's installed. So I can now say, connect AZ account. It's perfectly fine. And it will prompt me. It installs some things, okay? And then it should probably start prompting me for a username and password if everything goes right, which hopefully it does. Yeah, there's my browser popping up. I've already got a username here because I did this demo earlier today. So I've got a user called Testy in a certain domain. I'm going to enter the password now, which I believe is this. Or maybe it isn't. Right, I reset the password. So let me quickly reset the password of this user and copy it over here. And it will ask me to reset the password again. So let's create a random password. And let's sign in. So this user account will be reset anyway. So if you want to screw with this user account, you have to be quick. And it says, I'm connected. It shows me I'm connected to something. And I could do more stuff. So it all works fine. So I accidentally installed a module with a wrong name. It still works fine. What happened on the background? Well, before I show you what my naughty module does, let's go to this path on my machine. And here, a file is created. This file was created like a minute ago. At least I'm on UTC now, I believe, or at least here in the bottom right, it says 8 o'clock. So, and here my whole access token is shown. For now, it only saved it to my hard drive. It could have also sent this access token somewhere else. Because what you've just witnessed was this module, which is called AZ accounts with 3 C's. It has a function connect AZ account, and it installs the normal module and then kind of wraps around it by giving the normal module a prefix and then still doing the connection, but also getting the token and storing it somewhere. I could have just as easily send it to a storage account or whatever. I was lazy here and I only made the connect AZ account, but I could very well also make the function for every function which exists, and you wouldn't notice it. In my module or in my manifest, it also says it's created by Microsoft. So if you would download this and you would check it, it would just say it's created by Microsoft. I've added some stuff of my own just so I can recognize it, but I could, if I want to, modify this to look exactly like the one you just saw. So that's not good. At least to me, that sounds like a problem. It's a problem we call typo squatting. And it's something which is in the news quite often nowadays. Not only with PowerShell, but with many different programming languages. In a programming languages or a scripting language as PowerShell, like PowerShell, people are not that aware of it yet. But people who work with Node or Rust or Ruby, they've been encountering this problem for quite some time already. Because a lot of these programming languages, they work with a public repository which contains a lot of codes written to support us, to help us develop things easier. If somebody has written a certain function which is just useful, they upload it to these repositories so everybody can use it and they don't all have to make their own version. But by just adding some small typos in there, I can very easily add my malicious code to this repository. And if somebody makes a small typo while doing it, the code still compiles, it still works, so they don't notice. There is a link in the bottom if you want to know a little bit more about it. So if you say, for example, a language like PowerShell, which many of you might be familiar with, many of the PowerShell modules are standalone. They don't have dependencies, at least that's what they say, and many scripts also. But if I go to GitHub and I just search on GitHub for install module, I get almost 91,000 results. This is from quite some time ago, so this number might very well be a lot higher by now. So there's still many scripts and many modules which do an install of a different module. There only has to be one which has a typo and could in this way be compromised. Because how does this attack chain work? Well, I'm a developer. I'm developing some codes. I look up the code. Well, we all know where we look up the code. We look it up at Stack Overflow, Stack Exchange, these kind of sites. And I get a script. I might alter the script a bit. Maybe I include the typo in there. Maybe it was already on the site. Who knows? And I test if I test if the code works on my laptop or my developer environment, whatever. And it works. It downloads the dependencies. They work. I have no idea that I've actually downloaded a malicious dependency at this point. That I open up maybe my environment for somebody malicious to enter. After I've tested it locally, I will probably run this code on a server in a production environment. I might need to do some changes. Maybe I was connecting to a production environment with my code, and this way they could spawn me. And if I run the things on this production environment, they will also download these dependencies, and maybe even these dependencies could open up more problems. Maybe they could even open up the whole server for other attacks. They could include backdoors in my environment. I don't know what code will execute on the background. Now, this sounds scary already. At least I hope it sounds a bit scary. Now say that I'm a malicious attacker. I could even go to these sites like Stack Overflow. And once I've written my malicious module, which is a typo squad of a existing module or dependency or package or whatever in any language, I could actually start providing help on these forums, on these places. And I could just provide code to these people like, hey, you've got a question? Here is code. Sometimes I just give a good result, which works, doesn't have anything malicious in it. I build up points. And sometimes I add in one of my own modules, which is just a typo squad if they ask the right question. And they can download it, the code works, and it happens without you noticing it. It's quite hard to spot these typos. So this is something which actively happens in multiple different coding communities. It is something we see happening. So it's really hard to spot these problems. And only doing it once can be enough. If, for example, I run the script I just showed and my token was compromised this way, even if afterwards somebody noticed like, hey, actually it says something wrong. Well, it did work, but let's fix it. I still have this token. I could use it to keep refreshing it and still access the environment, or maybe use this token to create a new admin account for me if they logged in as an admin. So AI, it will save us, right? ChatGPT to the rescue. That's what I hear people say. So I hope you can read this. Yesterday, I was sitting in the train and I needed a little bit of help with writing a script. So I went to Bing Chat, Copilot, and I asked him, can you please write me a PowerShell script to get some messages from WhatsApp? I'm using WhatsApp for some stuff and I wanted to get some messages from a conversation. Of course, I don't want to maintain my code that much, so everything which can be reused from public repositories, please use it. So my code is nice and simple. And give it some comments. So that was my prompt. And this is the result I got. Do you spot a problem in this code? So this one is a lot harder to spot because the problem is here. It looks completely fine. Import module WhatsApp. But if I actually go look up if the module WhatsApp exists at either the PowerShell gallery or by using PowerShell itself, this whole module doesn't exist. This is something we call hallucination. I think I actually accidentally have this sheet twice, I now see. Indeed, in the chat, it's also said that there's no authentication. This is a hint already. My theory here is I've tested this with several different prompts, and sometimes I asked this, sometimes I got an answer which where it said, hey, this module just doesn't exist. I don't have anything for it. And sometimes it gave an answer like this. My theory is that at least with something like the Copilot in Bing, that it kind of is able to communicate with this PSGallery. You see it doing some searches, and it sees that there is a module, a PowerShell module for WhatsApp. There exists one, but it's not to get messages. It's just to update it. But because it sees that it exists, it now assumes that this module will probably follow things it knows, because it knows how to get messages from several different things. Because in the end, these AI tools, they are text predictors. They don't understand what they're talking about. They're just predicting text. So it now starts predicting like, okay, so this module will work this way. And maybe it's able to get some of the help files to get a more in-depth view of it. For example, if I asked it about Signal, a different messaging app I'm using, it gave me a very nice script, but it was using the az.signalr module, which is something for Azure to communicate with specific storage accounts to get data from analytic data. So it was very confidently giving me wrong answers, which is a very big risk of AI. And this is also an attack vector people are already using. Because nowadays we have a lot of Copilot tools to assist us with programming. So attackers are also using these tools, and they are testing these tools, and they are asking these tools questions which other people would ask. And if they notice these tools are hallucinating certain modules, certain plugins, or whatever, they create them. I could now create a module, WhatsApp, maybe have it prompt a fake login page for Meta or WhatsApp or whatever. So if you use this code, it will prompt you with a login screen. There's no auth in it, but maybe I didn't say that it had to run inattentively. So having a interactive logon would be a answer which work for the prompt I gave. So you could see the script and you could test it, and it gave you an interactive login, and you would be like, ah, nice, okay, it works for one time, it's okay, and else I would need probably to provide some way of a token or an authentication to it. You log in, and it doesn't give you back the answer, but by now I've got your credentials, because you only have to make the mistake once for me to win. And you could report this module if the place where you're downloading it from has a reporting option and you actually noticed it, that it was because I did something naughty and not because you did something wrong. Because a lot of the times if we're running code and it doesn't work, we think the problem is with ourselves and we start troubleshooting. So before you know it, you've been troubleshooting, you're like, okay, maybe I did something wrong. There's no proper help files. Let's just try a different way. And you don't even report it because you don't know I just stole your credentials. So it's very easy to use tools like typo squatting, to use tools like AI to easily get you to do things I want. And it becomes even worse if you use programming languages which have a lot of dependencies and are built on top of each other with different dependencies. Languages like JavaScript, some modules or some things in JavaScript you use, they download half of the internet to get all the different dependencies they need. If you have one of these dependencies which is very early in the chain, you can quite easily infect a lot of different things. This actually happened when the war between Russia and Ukraine started, where somebody had a very simple JavaScript package, and they just added a console log message in there saying something like, please support this and this party. And they added it mostly just to show support, not seeing that because this package was used by some other things again, which was used by some other things again, which were quite popular, which were used effectively by all the WordPress sites on all of the internet. So once they started updating, suddenly all the WordPress sites on the whole internet started showing this log message in the logs. So when you pressed F12 and checked the console out on a website, it was showing this. Just because somebody did this for a quite simple package. This was a wake-up call for most of the developer community for this specific language. And also one of the reasons people started looking into this more and more again. So what can we do as admins, as developers, as IT experts? Well, there are tools available. We can do things like code scanning and testing. But a proper built malicious package, module, whatever, might still work. And scanning it can be quite hard. It's very difficult sometimes to distinguish between malicious code and non-malicious code. Also, for example, in PowerShell, in the module manifest, I can actually enter whatever I want. It's not checked at all. So if you're going to scan this and you're going to scan, for example, will only use Microsoft provided dependencies, it would still show up as being Microsoft. Code signing is something which is often said. So for some programming languages, I believe by now they're getting to this point where you can actually properly validate it. But a lot of the time, the code signing is mostly used to check that the code is not tampered with in transit. So between where you're downloading it and where you're using it. So you can check this, but it's not used to, for example, validate the person who actually made it. That if Microsoft provides a piece of code, I can use the signature in the code to actually check if this was really made by Microsoft. I could use the public certificate from Microsoft to check this. This is not often the case yet. For example, in PowerShell, this is not the case. We can do code signing in PowerShell, but only to check that the code has not been tampered with. So what we mostly want to do is to protect and to audit our supply chain. And with supply chain, we mean the things we're getting from different places to create our own product. And when we're doing software, when we're doing scripts and we're taking in different pieces of software to support our product, this is also a supply chain. This is also something which was shown a few years ago with, for example, the SolarWinds hacks. SolarWinds was hacked and was injected with malicious code. And because a lot of companies were using SolarWinds, suddenly they all also got this malicious code in their environments. And before you knew it, places like some of the big IT companies were infected by this because they were not properly protecting and auditing their supply chain. By now, they're doing this more. So there's many different ways to do this. I want to present you with the solution, how you can do this in Azure DevOps. So if we're seeing the PowerShell gallery as a repository providing all kinds of code from different people, and I have my machine where I run the code on, then I want to put in between what I here call like an intermediate store or feed. which I can use to actually audit and check the pieces of software in there. So I kind of want to have a place where I download the things from the public place too, where I can check it and I can vet it. And only if I say this is correct, it can move on to actually my production environment. So let's build this and see how it works. And let me share my screen again. So I'm back in Azure DevOps. And let's first go to artifact feeds. And here you see my fake PSGallery we were connected to earlier. This fake PSGallery has the AZ accounts with CCC. In Azure DevOps, you can make something which is called an artifact feed. And these feeds can contain packages. In this case, they're NuGet packages, and PowerShell is able to download NuGet packages and use them to distribute PowerShell modules. They also support many different types of packages. I've also got a staging feed. This is a feed I created before. This is my intermediate feed. So in my staging feed, I can create something which are called upstream sources. So what I'm doing is I'm saying in this feed, you can search for packages in this specific feed. So my feed is able to check in a feed above and get packages from there inside itself. So if I want to add another package to this feed, I could upload it to this feed like a internal piece of software we're developing and I want my developers to use. If it's internal, I probably trust it. But I could also check, for example, the PowerShell gallery. I recently created a new PowerShell module. I believe it's called geocoding. So maybe I can just find it if I search for it. Yeah, I found one. So I could say save to feed. I think this is mine. I'm actually not completely sure, but we can just edit. So now if I go back and I refresh here, you see that it added this one. I can click on it, get some more information. This description looks quite familiar. So I think this is my module I just added. It also says that the author is mine. So I actually found the right one. It shows me the stuff. So it now just downloaded this package from the PowerShell gallery into my feed. This is nice, but if I would connect to this feed directly with my scripts would also be able to use this upstream source directly. Because this feed is able to connect to the PowerShell gallery, somebody who's querying this feed also would be able to query this upstream source. It only can do one step. So what I need to do is I need to create another feed. Let's call this super secure feed. It's visible for everybody. I'm going to disable the include packages from common public sources because I want this feed to be isolated and not being able to take things from different sources. And I'm going to create it. Now I've created a new feed. I'm going to the settings, to the upstream sources, and I'm going to add a feed for my organization. And here I'm going to look for the staging feed. and I'm going to say NuGet packages. Let's save this and let's go back to the feed. So now if I would search for upstream packages, and I would search, for example, for now, let's say AZ storage. I think that one was not in there yet. Oh, we did have that one in the staging feed. Let's see. Ah, it was, sorry. AZ SQL is not in there. So let's search for az.sql. It is finding it now. That's right, because we're doing it from here. But if we're doing it with PowerShell, it shouldn't find it, sorry. Now I should be able to connect to this feed. So let's do this. I'm going to move this one to the side. And let me just open a new notepad for a second. I'm going to copy this piece of code to connect. And here I'm going to change the name to the super secure feed. The rest of the code is the same as we did before. So now I'm going to set up the connection. I need the token again to connect because it's a private repository, so I always need to authenticate towards it. And now I believe if I should do find module, az.accounts with CCC in the repository secure PSGallery. It can't find it. If I'm looking for the normal one, it also can't find it because we don't have anything with this name in it yet. Now, if we go back to Azure DevOps, and here we're going to search for ac.accounts, which was in there, right? ac.accounts, it's in there. Am I doing a typo now or? Oh, accounts, sorry. ac.accounts. I can add this one to the feed. And if we refresh it, we now have the valid AC accounts in here. So let's go back. Let's see if we can find the valid one now. Should be able to find it now. Oh, yes. Sorry, I also, of course, need to enter the credentials. We called it adocred. Reading the error helps. And let's also add the S to it. So we find the proper one. And if we find for the malicious one, if we look for the malicious one, we can't find it. So now by using this secure gallery, I made sure if somebody would run this code provided, they wouldn't be able to download this module. So if I say, find this one or install it, it would go okay, but not with the other one. Even more interesting, this is the latest version it shows. But now if I would just say, look for it normally, and do the list available. I believe it's just called PSGallery. You see that on the PSGallery, it's actually version 2.16.0, while I'm only here on 2.11.2. If I would go back to my staging feed, in the chat, they say, well, maybe do all versions. So we can check. This is the secure PSGallery, all versions. It only shows me these two versions. In my staging feed, I only have these two versions at the moment downloaded to it. If here I'm looking for AZ accounts, it's showing me all the other versions. This is the version I have in the feed. I could just add a new version here in my staging feed. So besides using it for kind of allow listing which modules can be used, I can also use it to allow list specific versions of the modules. I could, for example, make a staging feed for production and a staging feed for my test environment. And in my test environment, I can always allow the newest version, make sure it's in there. In my test environment, then run all my tests, check if there's any regression. And only after all my tests are done, I can allow these versions inside my production environment. And I can all manage it here, and my scripts would then automatically update themselves if I would put this in code. And I wouldn't need to do version pinning in my code. I could, in my code, just always make it have download the latest versions. And I can just manage it here. So I could have a security officer or a security team manage which dependencies are allowed in my environment. Instead of them checking it and then saying to developers, well, you're allowed to now use the newest version. You can update your dependencies to display the newest version numbers. If you want this or not, this is a different question. Maybe there's reasons you want to have these versions pinned in your code. It's also a very good reason. But still, this also allows you to actually vet these dependencies. So if somebody would come to you and says, hey, I want to run this script in my production environment, but it doesn't work because this module is not scanned or not available for us, you could check it. You could properly do a test for it. Like, is this really the one you need? Is this really a good one? Most of the stuff is open source. You could actually check the open source code. Still, there's a risk because it's hard to spot these problems, but it gives you a lot more control. And this way you can manage which ones are allowed and which ones aren't. So I will get to the question in the chat after we're done. So there are some disadvantages of using this. At the moment, I still need to use a PAT token, a personal access token. There are options to automatically renew this. There's a link in the description how you can do this. Service principals are now supported by Azure DevOps. So you could connect to the staging feed or the feeds by using a service principal, but PowerShell doesn't support this yet. So you can't use it with the PowerShell thing. So if you're using a different language, which has options to download packages using like service principals or other ways of authenticating, it would work and you don't need a token anymore, but with PowerShell you still need. There is some more maintenance required, but it gives you more control. And some updates might hit production less quickly. So if code was updated, you still need to push it through production before it's actually there. It's not automatically updated unless you automate this process again, but yeah. So these are some disadvantages, but in my opinion, it would be worth the risk. Like we said already, you've got version control over the modules. You can have multiple feeds for multiple environments. So you could have this staging feed with all the accepted things, but for every different environment, you make this new secure feed. So you could actually see which environments use which dependencies. Because you saw once we used this module, once we download it and install it, it will show up in the feed, and it will also show how often it's downloaded. So I also have usage statistics. So it gives me a way to actually see which dependencies are used where. So if I, for example, have multiple systems running PowerShell code, I could easily see which dependencies these environments use, because these would be the ones in my feed. And I could also see how often they're used. And if I have like recurring scripts running, I would see the number behind these modules will be about the same. And if there's one showing only once the number, I know probably somebody used this to do some administrative tasks, and it's not in the normal system which we run. And with this, I'm at the end of the presentation. If you want to know more about me, you can check my blog, ordersysops.com. Today, I posted a new post about using GitHub Actions to analyze some sustainability data from Microsoft. So if you like green IT, you can check it out. And yeah, now time for some questions. I saw we had one question in the chat already. So shall I just continue with this question?
Yeah, please.
Okay. So Ellen asked, what happens if you want to use a meta module? You want a phrase, say AZ preview or MS graph. So the AZ module, I believe, is like a collection module, collecting several different ones. So this would just work because it's also in the gallery, so it would download it. But if it wants to download the different dependencies it's using, these would all also need to be approved again. Does this answer your question, or are you looking for more? Good.
Yes.
It was just whether you had to download effectively all the individual modules for it to
yeah.
do its stuff.
As far as I know, the AZ module actually downloads different things, so it would need it. If it was really embedded in there, so if you would really have a module with a dependency embedded in it, which in PowerShell you can do, it would work, because this would really be embedded in there, and it would download it, and it wouldn't download the other dependency.
Yeah, but so, like, for example, if you're using it locally, you say install module AZ or AZ preview if you want, because that actually adds a few more in. It's a bit misleading in some ways, that term, but
yeah. But it depends a little bit on how it's coded. So I believe the AZ modules, they're coded in a way where it would download the different ones.
It does indeed,
so,
yes.
So they need to be approved, but it's also possible if you make a module and you're using a different module in there to actually embed this in the code itself, to actually have all the files from this module inside the package. In this case, it wouldn't download it, so it wouldn't be checked, so it would work. But then you would see this also while you're doing your check from this module, because all the code would be in there. So anyways, you would always see all the code before you would push it to your production environment. Okay.
Yeah.
If there's no more questions, then I'll give the word back to you.